Okay, welcome back everyone. Next up we have Sam McBeth, a tech lead at Clicks, who's working on privacy and anti-tracking for Clicks and Ghostery products. We're really looking forward to it, and without much further, I'm going to hand over to you, Sam.
Hi. Yeah, thanks for the introduction. Can I put my slides up? Yeah, great. Okay, yeah, so thanks for the introduction. My name is Sam McBeth. Today I'm going to talk to you about auto-consent, as this is our effort to make opting out of consent pop-ups on the web better. So yeah, I'm a tech lead at Clicks. This is a search engine and web browser company based in Germany. In the last 5 years, I've been primarily working on Clicks anti-tracking technology, which is also integrated into the Ghostery browser extension. I'm also part of the team behind the whotracks.me tracking transparency website, which publishes the largest longitudinal data set about online tracking available. And yeah, so the work I present today came out of two issues we encountered working on our web browsers. Firstly, the way publishers responded to the GDPR with consent pop-ups was very frustrating for users. And we wanted to make it easier for them to use their new rights to signal to publishers that tracking is not okay. And secondly, that more aggressive measures we wanted to take against tracking by clearing browser storage more often would exacerbate the cookie banner problem because users would encounter them often. So yeah, you may have guessed this talk is about consent. If you use the web from Europe in the last couple of years, since the GDPR came into effect, you've probably encountered a banner like this. These are a very bad user experience because they stop users in their tracks and force them into a decision they don't want to make. Very few users will understand what the implications of their choices are. Furthermore, users who engage with these pop-ups will find sometimes hundreds of clicks needed to effectively opt out. A recent study into these consent pop-ups found that dark patterns and implied consent were ubiquitous. That design changes can have significant impact on opt-in rates. This means that publishers are strongly incentivized to deploy dark patterns and confusing UIs in order to obtain higher opt-in rates. Users have little chance against the resources being deployed to make them click opt-in. They do have a note in the paper that the fairly centralized ecosystem for consent management pop-ups should make it easier to apply pressure and improve the situation. So a quick note here for clarification. So under GDPR and e-privacy, there have been two types of banner proliferating across the web. These are the purpose of notice and consent, respectively. So on the top above is a notice. This is an informational banner stating what data is collected. The user can see more information about it or dismiss the notice. But the notice is purely to inform the user, and there's no choice the user can make in response. A consent pop-up, on the other hand, requires a user input. It notifies about what data processing will be done and allows the user to opt out of one or more of the purposes. Beware, there are also consent pop-ups that look like notices, but they hide the configuration options behind learn more links and others. But yes, in this talk, we're talking about these consent pop-ups, which are referred to as consent management providers, or CMPs. So yeah, since the GDPR came into effect, multiple providers have sprung up to provide CMP solutions for publishers. Here's a selection of a few. This is actually to our advantage, though, because it means actually there's a fairly limited number of different CMPs covering the majority of websites. So if we have a solution that solves automating opt-out for some of these providers, we automatically get very good coverage across the web. So just to give you a quick view of what these CMPs look like if you maybe don't encounter them very often, here's a quick example. So this is a CMP by OneTrust on the Atlassian website. This is just a random choice. It's not something. Just picked one of the examples I have. So yeah, initially we get a banner along the bottom of the page where we can either already accept cookies or we can click cookie settings to configure custom settings. If we click on that one, we get another menu where we can go through the various different categories on the left and turn off most of these options. So except strictly necessary cookies, we can toggle these off. When we get to the end, we just have to make sure that we click Save Settings and not Allow All, otherwise all the work we've done is removed. So in total, it takes at least 8 clicks here to opt out, and that's if we're already familiar with the UI and can do the optimal click path. And obviously, it's just 1 to opt in. So yeah, what's the problem? There's many problems with this current state of affairs. So firstly, users experience many pop-ups that degrade the web browsing experience. As we have seen, opting out is difficult and time-consuming, and this pop-up fatigue leads to user apathy about their privacy rights. Publishers are also incentivized to try to get higher opt-in rates, as ad tech rewards more tracking with better ad rates. The lack of enforcement against these dark patterns, plus the complexity of communicating privacy choices, have led to this toxic ecosystem. And finally, this privacy wall that's now in place across many websites increases the cost of anonymity on the web. So a returning user now gets a much better user experience as long as they opted in on their first visit than a new visitor. So approaches to align browser storage like cookies with user expectations about how long a site remembers them will now degrade user experience. So what we want to do is we want to try to solve these issues around CMPs. To do that, what do we need to do? So firstly, we want to make opt-out just as easy as opt-in. This is a key requirement such that to give users a fair decision without being penalized. So they don't choose to opt in because they think it's going to be easier that way. Secondly, ideally, it should only be 0 or 1 click. So either the CMP is automatically dismissed when you land on a page, or the browser just asks a simple opt-in, opt-out question, and a single click is sufficient. So adjacent to this is also that we want to simplify the options to just a binary choice. Generally, all the different categories offered by these banners are too complex for most users to understand. Finally, we'd also like to reapply this choice if the site asks again. This reduces the incentives for sites to periodically reset consent if they don't get an opt-in, which is something that many sites currently do. So at this point you might be thinking, well, we already have tracking protection and ad blocking enabled. Why do we even need to bother opting out to? And we're already protected. Well, to some extent, yes. So tracking protection does provide protection on a technical protection from third-party tracking. However, opting out via consent pop-up adds a layer of legal protection to your technical protection. So while technical protection makes it not possible to track you, legal protection makes it illegal to track you. So this is good to cover any gaps that you might have in your protection from particular types of tracking, and in general then make your privacy better protected online. Further, there's also very little done by current tracking protection and ad techniques and ad blockers against first-party data usage. Consent, on the other hand, can control what first parties do with third-party data, or with first-party data, sorry. Finally, also, metrics from CMPs are collected by publishers to measure user acceptance of their data policies. Due to the current design, many publishers report extremely high opt-in rates, but studies have shown that these don't match up to what users would grant if consent was properly informed. So by opting out, we can send a signal to publishers that tracking is not acceptable and help push a demand-side shift to more contextual advertising. But so why aren't ad blocker rules sufficient for this use case? Can we just write a filter list that's going to block all these pop-ups? Well, for some CMPs, they are. So if we use, for example, some of the popular annoyance filter lists, we can prevent some CMPs from loading and pop-ups from being shown. So theoretically, this would then leave the site in a no consent given state, which should be interpreted as opt-out. Cosmetic filters could be used to hide some of these pop-ups, but this is generally really only applicable to notices. And the main limitation of Adblocker rules for this use case is that they don't support clicking on elements in the DOM, and particularly a more complex sequence of clicks that would be required for these CMPs. This is a good limitation for filter lists to have, because there's a lot of dangerous stuff that could be done with this ability. But for this use case, it would be needed because user interaction is required for consent. So what about standards? Dealing with user consent is now a general problem that thousands, if not millions, of websites have to handle. It should be a good candidate for standards to mediate the exchange of consent between the site, the browser, and the user. And there have been a few attempts to standardize consent expression for websites. So two older standards, there's the Platform for Privacy Preferences, which is a standard for negotiating consent between the site and the browser using machine-readable privacy policies. This was only really adopted by Microsoft and is now deprecated as generally seen as too complex. There's also Do Not Track. This is a simpler proposal for browsers to broadcast consent or the lack of it to websites. Also supported informational HTTP headers sent by the sites to indicate what data processing they are doing and if they believe consent was given. Despite cross-browser adoption of Do Not Track, the major tracking companies did not honor the signal because they had no legal mandate to do so, which led to it be mostly useless and is at this point being removed from most browsers. So both these standards dealt with interaction between the browser and the website in both directions. So the browser would send what the user's consent status is, and the website would set something back to say, okay, this is what we do with data at the moment. The other recent standard around consent is the IAB Tech Lab Transparency and Consent Framework. And this is trying to deal with the problem of valid consent for the ad tech ecosystem. So this is an industry standard that's largely focused on helping publishers communicate user consent to advertising partners, and not for browsers to read or modify user consent. So because that is communication between the website and the third-party advertisers, there is no boundary for the browser to communicate consent to the website. We did do an early prototype at Clicks called Reconsent, which tried to use this IAB framework to display and update consent settings, but the lack of standardization on this creation and storage of these consent strings made it not work particularly well. Furthermore, the sites using this framework is actually just a fraction of sites using consent pop-ups. So, in the absence of a suitable standard to allow the browser to express the user's consent for them, we take an approach of adversarial interoperability. So this approach says that if the only interface given to us is a consent pop-up, we can automate our interaction with that for the user. This name comes from a recent paper by Nuance et al., which proposed the same approach as the auto-consent system I'm presenting today. This is essentially writing rules that define click paths through the CMP UI. So the auto-consent system follows a simple flow. When a page is loaded, we firstly check the set of rules we have to see if one matches for the current page. These rules will check for specific elements in the page that indicate which CMP is in use there. Once we've selected a rule that's relevant for the current page, we can do a further check to see if a pop-up is being shown. If the pop-up is shown, we can check the user's consent preference for the site. This may already been set previously, or we can pop up our simplified consent interface to get it. It's important that we do get an explicit user consent so that we can act as an intermediary for the user, and that the consent we submit on the site is valid. Once we've decided what the user consent is, then we can run an opt-in or opt-out steps through the CMP and dismiss the UI on the website. Finally, some CMP rules we can write a self-test to check if the rule works as intended. So, i.e., does the site think that the user opted out or opted in? We can, for example, use the IAB framework here to check what consent is being passed to third parties and if it matches the one that we thought we set. So these steps I described translated into a programmatic rule interface with these methods. And these all take as an argument the page we check on, where we have an abstraction of the methods for interacting with that page. So yeah, for the detection part, so when we want to see if a CMP is in the page and if a pop-up has been shown, we have the following methods. So we have an element exists methods for checking if there's a DOM element matching the given selector on the page, the selector just being a normal CSS selector. Elements are visible, further checks that elements matching the selector are visible to the user. And then we have eval, which is just like a JavaScript eval, so evaluates a particular snippet and then returns if the result was truthy or not. Then we also have methods for actions, so allowing us to interact with the page. So once we've done the detection phase, we can click through the UI. So first two are dealing with clicking on elements, and we can also click on multiple elements at once, just from a CSS selector. Again, eval can also be used in this context to do interaction. So in some cases, the CMP will expose JavaScript API to the page that then we can invoke. Then we have two wait for methods, and this is for pausing the rule execution flow until an element exists in the page or frame. This is useful for cases where it takes some time for the UI to update after clicking a button. Hide elements just as a simple CSS hide of elements, so we can hide things from the view. And finally, then we have wait, which is another simple delay mechanism. So this is for some cases where we can't interact with the UI so fast because of some race conditions in the code. So you may have noticed that these methods also take an optional frame ID argument. This is because often CMP elements are put into iframes. So this allows autoconsent rules to target specific frames. So when we have a page with multiple frames in it, what we can do is we use the URL prefix to select what URL is the frame we're interested in, and then we can target the detection and click actions to that specific frame. So for example here, this is on Zoom's website, which uses a Trust Arc banner. And this is inside a frame. So we specify the OneTrust URL of the frame they use for the consent pop-up, and then we can target our clicks at the buttons in that frame. So this is a quick run through of what a rule looks like when it's specified in code, in this case the cookie bot pop-up. So here the detection of the CMP is fairly simple, because once the cookie bot script is loaded in the page, it sets this cookie consent object on the window object. So if that's there, then we know this is a cookie bot pop-up. Likewise, when the pop-up is shown, it has a well-defined CSS class or CSS ID that we can pick up and check for. There are a few different designs, so we need to check 3 different ones depending which pop-up design is being used. And yeah, so Cookiebot also has 2 different variants for opt-in. So some will have a direct opt-in button, and others we have to check boxes and accept. So this demonstrates that when we use the programmatically defined rules, we can actually have arbitrarily complex logic to deal with dynamic pop-up UIs. So when it's very complex, or there's different paths you can take, we can all write this in code here. Opt-out is similar, a bit more complex in this case, because again, there's a few different paths in the code, depending on how the publisher configures the tool. Finally, we can implement a self-test for this one. So this is to check if an opt-out worked. In this case, Cookiebot exposes this on their JavaScript object. So we can just check if this declined attribute is true. And then we know that we were successful in opting the user out. So we can use this to run a self-check after opting out a user, and then, for example, report in telemetry if it failed, and quickly identify issues with our CMP rules. For simpler cases, we also support declarative specification of CMP rules. This is just a JSON format that specifies the actions or detections to do for each of the different stages. This method is more concise than writing a class for each CMP, and this also has the advantage of allowing rules to be updated without updating the extension code. So this is kind of more closer to writing filter lists. So as I mentioned earlier, we should also ask for user consent before we can make a choice on their behalf. So in the version of Autoconsent we shipped with the Clicks browser, we did this via an overlay on top of the page. So after I click Always Hide on this pop-up, then the pop-up underneath will be automatically dismissed. And also all future pop-ups you'll get will be automatically dismissed. So the challenge here is to present a dialogue to the user that they recognize as being from the browser, which is kind of a general issue for browser UIs. And particularly if you're implementing this as a web extension, it's very difficult because you cannot trigger page or browser actions without a user interaction first. So in this case, it's actually just another overlay that's put on top inside the page. But that's a kind of limitation of this implementation. So the Autoconsent library is published on GitHub as open source. And this library contains rules for most popular CMPs, and then the logic to run them in a browser extension. There's also then a bare bones example browser extension just to show how to use the library. Also, there's this abstraction layer over the interaction with pages. And then we have another implementation of this for Puppeteer. So we can use this, for example, to do web crawls and see what the coverage of different CMPs are, and also do automated testing of the rules. So a quick note on Consensusmatic. So the paper I mentioned earlier on about adversarial interoperability, part of that paper was also an extension called Consensusmatic. And this actually uses the same approach as Autoconsent for interacting with CMPs, but with more fine-grained control. So you can actually specify there every specific purpose, how to opt out of them individually. This was actually implemented kind of at the same time as we did Autoconsent, and we both discovered after we published our work that we've done the same thing essentially. But since then I've also added support for the Consensusmatic rule format in Autoconsent, so we get the benefit of rules written for that extension too. So there's a couple of limitations in this Autoconsent approach. So firstly, the markup used by some CMPs make it difficult to write reliable CSS selectors to reach the elements we want to click on. This is kind of a general trend, I guess, also familiar to filter rules writers, that interfaces written with some JavaScript frameworks have machine-generated classes and element IDs, or none at all. So it's quite difficult to select those elements. Secondly, changes to CMP UIs can break the autoconsent rules, so it requires regular maintenance to keep them working correctly. And particularly with the current increased attention on how GDPR compliant these pop-ups are, changes are likely when new guidance is issued or fines are issued. Luckily, we have this self-test mechanism, which should give feedback when regressions happen, so rules can be updated. Thirdly, there are some issues on some sites after opting out, which can be quite confusing for users when they don't see why this happened. So several sites will, for example, just redirect to a privacy policy or other page after you opt out. There's also some potential for conflict between autoconsent and ad blockers. So if ad blockers are blocking some part of the some resources that the CMP needs to work, then autoconsent may get stuck. Okay, so quickly to wrap up, what's the status of this project? So we released this back in January in the Clicks browser. It's to around 30,000 users. Then also we have a standalone extension version, which is this minimal version that's inside the open source repo that's on the Mozilla add-on store. This extension also works with the current state of Firefox Gecko view on Android. So you can run it in an Android browser. But so unfortunately, back in May, the Clicks discontinued their browser project. So since then, we haven't been able to move any further this project. So we're currently looking for a good project fit elsewhere. So if you're interested, please ping me on Slack. So thank you for listening. Happy to take any questions.
Thank you so much, Sam. The questions are going wild, and so is chat springing up all over. So we'll have to take the majority to the Slack channel, if that's okay with you. But maybe we can get through one or two quickly. So the top voted one is, do you consider eyeo's implied consent to seeing acceptable ads for Adblock Plus a proper type of consent?
So I'm not entirely familiar with this implied consent.
Okay, maybe then we take that one offline and people can flesh it out with you a little bit more so we can go in detail, if that's okay. Okay, then the next one is from Peter Lowe. Have you seen many people attempt to roll their own consent forms out?
There are, so the big publishers do. So the big websites, I think before I had an example from The Guardian and other big publishers will do it themselves. So for example, Clicks, our parent company, is Burda Media, which is a big German publisher, and they coordinated across all of their web properties their own solution. But the long tail, so the rest of the web, they all just kind of pick one of these off-the-shelf solutions. So I think WordPress, you just install some plugin for one of these and you get it on your site. So again, I think it's probably similar to in ad blocking. There are the big providers who most people will just take their offering off the shelf, but then the big publishers obviously will do something bespoke because they have the resources to do so.
Brilliant. Thank you so much. And there are so many more questions waiting and we don't have tons of time. So all that's left is just to thank you again. And yeah, everyone else head over to the question and answers channel because Sam will find you there, I guess.
Thank you very much.
Thank you.